The last section of this class is probability. We're going to start with some pretty simple situations, but once we build up a little experience and some knowledge about how probability works, we'll be able to analyze many situations involving risk and chance. So to begin with, let's look at some general terminology for probability. When analyzing probability, you have to decide what it is exactly that you're analyzing. And we're going to call that an experiment. So for us, an experiment is going to be any random process that produces a particular indefinite result. And while we look at this terminology, we're going to have a particular example in mind. And our example of an experiment is going to be just rolling a standard six-sided die. So when you roll the die, the outcome that you get will be the number that is on top, naturally. For any experiment, since it produces a definite result, the experiment will have a collection of outcomes, which are just the things that can happen as a result of the experiment. So for our rolling a six-sided die, of course you could roll a 1, or a 2, or a 3, or a 4, or a 5, or a 6. But an outcome is just a single outcome. It's not a collection of possible results. So for example, rolling an even number doesn't count as an outcome. An event, on the other hand, is any collection of possible outcomes, even multiple outcomes. So for example, in our die rolling example, even though rolling an even number isn't an outcome, it is an event because it's the collection of outcomes rolling a 2, rolling a 4, or rolling a 6. Also, other things that are events would be something like rolling a prime number or rolling a number bigger than 2. A simple event is an event with only one outcome. So these basically look just like the outcomes themselves. So rolling a 4 or rolling a 5 would be a simple event. And the last bit of terminology is the sample space. The sample space is just the collection of all of the possible outcomes. Notice that the sample space is also an event. So for our rolling a die example, the sample space is just the numbers 1 through 6. Just to look at another example of this terminology, let's look at drawing a single card from a shuffled deck of 52 cards. So the experiment in this example is just drawing one card from the deck. The outcome is any single card, like the King of Hearts or the Seven of Spades. An event would be any collection of cards that you might draw. Some collection of cards are easier to describe than others. So for example, one event might be drawing a diamond, or drawing a 7, or even drawing a face card. Other events are harder to describe, like saying drawing the 7 of clubs, or the King of Hearts, or the Ace of Diamonds. A simple event in this example is just drawing any one card. So for example, the Ace of Clubs. The sample space in this case is any card you might draw. So the Ace of Diamonds through King of Diamonds, the Ace of Spades through King of Spades, the Ace of Hearts through King of Hearts, and Ace of Clubs through King of Clubs. Now that we know the basic terminology for talking about probability, let's see how you actually calculate some probabilities. But what is a probability? Probability of an event is the likelihood that an outcome in that event will occur, and it's given as a number between 0 and 1. So for example, 0.5 as a probability means that that event has a 50% chance of occurring. There are events that have no chance of occurring, and the probability for those would be 0. Those are impossibilities. And any event that has a probability of 1 is certain to occur. Those are called certainties. Notice that if you ever get a negative number or a number bigger than 1 for a probability, you have definitely done something wrong. All right, so the notation that we'll use for probability of an event, first of all, we'll usually call our events E unless we have some better name for them. Just like a variable, you usually call X unless you have a better name for it. So we usually call our event E, and to mention the probability of E actually occurring, we will write P of E like this in parentheses. And if all of the outcomes in an event are equally likely, then the probability of that event occurring is the number of outcomes in E divided by the number of outcomes in the sample space. So it's always this ratio. Notice to know the probability of the event, you have to know what the sample space is so that you know how many things are in it. All right, let's look at some examples. So let's calculate the probability of rolling a 3 on a 6-sided die. So we know that the sample space in this situation is the possible outcomes for rolling the 6-sided die. That's 1, 2, 3, 4, 5, and 6. Okay, and let's write the event that we're calculating the probability of, so E. So the outcomes that we want to have happen are just rolling a 3. So this particular event is actually a simple event because there's only one outcome in this event. Okay, now we can write the probability of this event. So it's the number of outcomes in this event, and there's only one outcome in this event, divided by the number of outcomes in the sample space, and as you can see, there are 6 outcomes in this sample space. So the probability of rolling a 3 on a 6-sided die is 1/6. Let's look at an example with an event that's a little more complicated. Let's find the probability of rolling an even number on a 6-sided die. So for this example, the sample space is still the same as it was in the last example, just the numbers 1 through 6. And this time, the event is rolling an even number. So rather than just using the letter E, we could write even for our event. But still, we should list the outcomes that are included in this event. So since we want even numbers, we should list the even outcomes, so 2, 4, and 6. And so the probability of getting an even it's the number of outcomes in the event, and there are 3 outcomes in this event, divided by the number of outcomes in the sample space. And just like last time, there are 6 outcomes in this sample space. And so the probability of rolling an even number is 1/2, or 0.5 if you like decimals. So there's a 50% chance of rolling an even number. Those are a couple examples with die rolling. Let's look at drawing cards from a deck. So let's find the probability of drawing a 3 from a 52-card deck. So in this situation, the sample space is all of the cards in the deck. I'm not going to list them all because I have other things to do today, but there are 52 cards in the deck, so 52 of them. All right, let's write the event. In this case, the event is just all of the 3s that we could draw in the deck. So there's, let's see, there's the 3 of diamonds, there's the 3 of hearts, there's the 3 of spades, something like this. That's a spade. And the 3 of clubs, which, oh boy, I shouldn't have drawn these. I should have used letters instead of symbols. Okay, so there's our event, drawing a 3. Now to get the probability of this event, we divide the number of outcomes in the event. There are 4 possible outcomes in this event, each of the 4 3s that are in the deck, and divided by the number of cards in the deck, which is 52 cards total. All right, so 4 over 52, and I think that's 1 over 13, if we simplify that. And if you want a decimal, you can punch this into a calculator. If you find it informative, it's 0.0769 and a bit. There's a few more decimals there. All right, so now let's find the probability of drawing a heart or a spade from a 52 card deck. If you aren't familiar with the 52 card deck, here are all the cards. Each row is called a suit, each column is called a rank, and the column at the left, these are, instead of calling these ones for some reason, we call these aces. And the cards, three columns at the right, these are jacks, queens, and kings. And together, the jacks, queens, and kings are called face cards. Okay. So again, the sample space is just going to be all of the 52 cards in the deck. So our event is drawing a heart or spade. And rather than listing all of the hearts and the spades, just because there are a lot of them, let's point out on this grid of all of the cards where they all are. So the hearts are right here, and all of the spades, that one, those are the spades. Okay, so now we can calculate the probability of a heart or a spade. Okay, the size of our sample space is still 52. And now we need to count up all of the cards that are either hearts or spades. And if you count them all up, it turns out there's 26 of them. Of course, you can tell on this diagram that those 26 cards, that's exactly half of the cards. And sure enough, if you simplify this fraction, 26 over 52, you do get a half. So the probability of drawing a heart or a spade is exactly 50%. That's the basics for probability. What we're going to do in subsequent videos on probability is have a look at what happens if your sample space is a little more complicated, or what happens if you have trouble even counting how many things are in your sample space. Also, events might be a little more complicated, and your experiment might consist of multiple parts. All of these situations are going to make the mathematics of probability a little more complicated.